We're now going to take a look at a new type of equation. The equation we're going to be looking at is a linear equation in two variables. Now in the past you may have worked with solving linear equations, but these linear equations are going to be a little bit different than what you've worked with before. A linear equation in two variables is an equation that can be written as ax plus by equaling c, where a, b, and c are real numbers. Now your a, your b, and your c, since we're stating that they are real numbers, those are actually going to be constants. The variables here, when we speak of linear equations in two variables, the two variables are the x and the y. Now for an equation to be considered a linear equation in two variables, it has to be capable to be written in this form. What we need to emphasize about this form is that the variable, both the x and the y, is going to be raised to nothing but the first power. And when you're raising a variable to a first power, you actually don't have to write down the power. You can just assume it. So we want to see no second powers, third powers, or anything like that. Do not want to see any fractional powers like a 1/2 power. Do want to see any negative powers, and we don't want to see the variable written in the denominator of a fraction, because that actually implies, even though it doesn't directly state it, it does imply negative powers. And we'll say more later on about these particulars. But for now, what we want to talk about, what we want to concentrate on, is what a solution to a linear equation consists of. Now, since we have two variables, now let's just put down an example of a linear equation in two variables. Let's say we had a 3x plus 2y equaling 10. A solution to a linear equation in two variables is not an x or a y, because previously you may have solved some linear equations. A solution, since there are two variables here, is going to have to be an ordered pair with an x and the y that goes with it. Now, very often when you solve a linear equation in one variable, you're going to find there's one solution. Now, that's not the only thing that can happen, but it's the most common thing that does happen, is that you have just one solution. Well, now, since we are going to have solutions consisting of an x and a y, that's not going to be the case anymore. As a matter of fact, I can pick an x value. Let's say I was to pick an x value of 2. Well, I can come in and plug that x value in, and when I do that, that's what I'm left with is only one variable. One variable that I can solve for, and that second half of the solution is going to be the y value, and this constitutes one solution to this equation. Now, is it the only one? Well, it's not. I could come in and take the same exact equation, and I can pick a new x value. Let's say I was to pick, let's pick something easier. Let's go with 0. Putting that new x value in gives me again a linear equation in one variable, which I can solve. And here I have another solution to the same equation. And you're not just restricted to picking x's and plugging them in. I could come in and pick a y value. Let's say 3. And clear off the last solution. Plug in the y value we just picked. Solve. yet another solution to the same linear equation. So as you can see here, we can have more and more and more. The more x's you pick, the more y's you'll find to go with them. The more y's you pick, the more x's you'll find to go with them. So a linear equation in two variables can actually have an infinite number of solutions. And we'll find that if we were to plot these points, and we'll see that the reason these are called linear equations, if we plot these points will fall on a straight line. That's, again, why it's called linear. So if you were asked, is a given point a solution to this equation? All you have to do is take the first element of the ordered pair, which will be your x value, plug it into the x. The second element of the ordered pair will be the y value, plug it in, and see if it gives you a true statement or not. And by true statement, of course, we mean, do you actually get equality at the end like you should? So let's try a couple and see if we can determine when we do and when we do not have solutions. We'll start off with a fairly easy example. Let's say we had y equaling x plus 7. And these will be yes, no, true, false type questions, of course. Let's say we had the ordered pair 5, 12. Is it a solution? Well, making the appropriate substitution, putting a 12 in for y, a 5 in for x, doing the arithmetic, we find that 5, 12 is a solution. Let's come up with a new one. Let's take a 3x minus 2y equaling 6. And let's try the ordered pair to 0. Again, the x value is 2. Make sure you get everything in the appropriate place. The y value is 0. Doing the calculations. Again, we have another ordered pair that is a solution. Let's look at one more ordered pair for the same equation. And the next ordered pair we will look at is a -3, -4. Let's see, this is going to give us a -9 plus, when minus and minus make plus, 8, which is -1, which in fact does not equal 6. So -3, -4 would not be a solution to that equation. So there's your introduction to linear equations in two variables. Again, they have an infinite number of solutions, an x and a y value that, when plugged in, give actual equality, can constitute a solution, and when graphed, all the solutions to a true linear equation in two variables will fall on a perfectly straight line.